So, percents. We're going to go over two little things about percents. Just two things that you must listen to, learn it, put it in your brain, and then hold on to it for when it ever creeps up. Just two little percent stuff that you need to know. First things first. Wow, look at how thick that is. 25%. If I were to ask you, convert this to a fraction. So fraction is obviously something that we've been working on. How would you convert 25% to a fraction? Well, when you want to convert any percent to a fraction, you must put the number from the percent over 100. Why? Because percents are out of 100. There's nothing greater than 100%. Can you have something greater than 100%? Of course you can. In the business world, you come across that all the time. Let's say you've opened up a little hot dog shop in front of the school and you're selling them. You're probably selling 2 hot dogs in the day for $2 each. Your total profit is $4, right? Well, let's say in a year or two that same business of yours becomes a chain, it becomes famous, and you're selling millions and millions and millions of hot dogs, making millions and millions of dollars. Well, you just went from from a $4 profit to millions and millions of dollars. You went a lot more than just 100% increase in profit. You went over a lot more than that, right? So in business world, you come across a lot of stuff that is over 100%. But in essence, no, there's nothing greater than 100% in real world stuff. So any percent you come across should be over 100. So you just make it into a fraction, 25 over 100. Okay, that's nice. Is this my final fraction? No, because this could be simplified. And if you use your simplifying techniques, what you realize is actually 1 over 4. So 25% converted into a fraction is 1 over 4. Any percent they give you. If they give you 90%, all it is 90 over 100. What's that simplified? Well, you could just do the trick that I showed y'all, an eye for an eye, take out a 0, take out matching zeros, and what we end up getting is 9 over 10. Which cannot be simplified anymore. 9 over 10 is the fraction equivalent of 90%. Is that pretty straightforward? Cool. Please take note of that because it might creep up in the near future. Wink, wink. Hint, hint. Thursday quiz. But there's another little question or something that you might be needing to convert, which is when you're given a percent as well, but you're told to convert it to a decimal. Do we remember how to convert this to a decimal? Does anybody have any idea?
Put a point in front of it, or a decimal in front of the...
Yeah, so 25%. That is not a decimal, my friends. 25% is 0.25 in decimal form. Why is that? Well, let's just look at the 25 for a brief second. If we were just look at a 25, where is its decimal at? If you recall, I think the first week it was, I told you a whole number has a lot of hidden stuff around it, right? It has an infinite amount of zeros in front, an infinite amount of zeros behind it, has an over 1, it has a power of 1, it has all these invisible stuff. Well, like I said, it has a 0.0000 infinite amount, but yes, it does have a decimal right there. It's just not there. The thing is, you want to get that decimal and move it. Where do you move it to? If you're converting a percent to a decimal, you move the decimal 2 places to the left. So you physically just get this decimal and you move it 2 steps forward, making it 0.25. That goes for anything, my friends. If you are given the problem of 6%, what is its decimal? Well, where is its current decimal? It's right there. So you move it 2 places, and in this specific case, you had to add a 0. 0.06. That's the decimal of 6%. What if your percent already has a decimal? Well, that's even easier because it's not hidden. It's actually visible. You just start wherever the decimal is. For instance, if you are given 15.2%, 0.25%, let's say. 15.25%. Well, where's its decimal? It's right there, right? So you start there and you move it to the left 2 places. So from here you go 1, 2, and yes, it is 0.1525%.
We have to move it always.
Always to the left, always twice.
Okay, but for single digit, also twice. So we have that.
Also twice. And you might get a weird percent. Let's say your hot dog stand went from $4 to for net profit in the day, and then the next day it made $4 and I don't know 2 cents. You might have a percent increase of a very small percent, right? So you could get really small percents, 0.006%. Okay, it's still a percent. It's a percent with the decimal, yes, but it's 0.006%. How do you convert this to a decimal? The same way. Go to your decimal and move it 2 places. It's there, 1, 2. Guess what? You have to add 2 extra zeros, but you now have it as a full-fledged decimal. A number that doesn't have a percent in it. It is a number that you could multiply with, you could add with, you could do anything with that number now. It's a decimal. The trick here is just knowing that you have to move it to the left always. Does everybody got that? Does anybody have any questions? So, yesterday we went over ratio and proportions, am I correct? Well, today we're doing percents, yes, but we're also doing percent proportions, which is the same thing as yesterday, just with a little different format. Let's see if I could pull it up here. Hopefully I can. Hopefully I still have it. So, yesterday we were going over traditional proportion problems. Today we're going over percent proportion problems. So, percent proportions, what do you got to watch out for? What's the difference between percent proportions and the proportion questions from yesterday? Pretty simple. This word problem has a percent in it. Am I correct? So if it has a percent, you know you're going to be doing the percent proportion. Well, in order to solve a percent word problem, a percent proportion word problem, you must do the same thing you did yesterday, which was create your setup. Do we remember what the setup was? It's one fraction equaling another fraction. Sorry, one ratio equaling another ratio. You want them next to each other. Thing is, percent proportions are a little different, as in they have its set template. The percent proportion has its actual designated spot for these numbers. How does that template look like? It looks like this. 3 little words that you are going to want to learn, which is part, base equals rate over 100. This looks just like yesterday's proportion problems. It's a template though. And we're going to know what these 3 words mean so that we could put our numbers in its designated spots. So, first things first, let's start with the easy one. Rate. Rate, my friends, you guys want to think of it as the percent of your word problem. So in the word problem, you're going to be given a percent somewhere. Guess what? That's your rate. Pretty straightforward. The base. Think of that as your total of whatever it is that your word problem is talking about. And don't worry, we're going to look at this example up here. Right now, I just recommend writing this down for your notes so you can practice it, because you are going to want to memorize this template to a T. And the part is pretty much the part of the base, as in the piece. It is the piece of the total. And yes, you're right. 100 will always just be 100. That's just always there. Because again, percents are always over 100. It's just 100.
Okay.
Who said okay?
Me.
Oh, yeah.
I read something on your.
So the rate is the percent, and it's always going to be over 100. So let's memorize this template. Let's have it here on the side. And let's look at this word problem up here. At a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, part, and rate in this situation. Okay, so I want to set it up just like this, my friends. I want to set it up just like yesterday. I want to set up my setup of the given situation. So tell me, you could immediately do that if you want, over 100. It's always going to be there. Tell me, in the given word problem that I just said, what is my rate? 15, because that's the percent. Tell me, what is the part and base? That's, I'm telling you right now, distinguishing what the part and base is probably going to be the hardest part when one of the numbers is missing, which we'll do next. But right now we're just trying to identify what each of those numbers, where you would put them in the template of part, base, rate over 100. So, what would be my part? $3. What would be my base? 20. Why is that? Well, 20 was the total amount of the bill, am I right? $3 was the tip. That was the piece. That was the part of the total. And they wanted to know, or they just wanted you to identify all that, right? So, you just identified the part, base, and rate. There's not math to do here. Right now we're just going over this first example to see how the piece might look like of a word problem, how the base might look like of a word problem, and how the rate is going to look like in a word problem.
So if we're looking for the rate, it won't always be 1? Because that's what it said on our paperwork that I had.
I think I need to see that paper. So, that being said, rate is always the percent in your percent word problem. What happens when one of them is missing? Just like yesterday when they gave us, for every 3 bananas there are 2 tomatoes or whatever it was. How many bananas are there in a fruit basket with 6 tomatoes? They wanted to know how much bananas there were. There was always a missing element. Missing pretty much. So in that specific situation, if I still have it and I could pull it up, your template, your part over base equals rate over 100 is always going to help you, my friends. Learning how to do the setup of a word problem is always going to benefit you. You must always do it. So in this specific case, if we read it, at a plant that manufactures lighting fixtures, it is expected that about 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? These math word problems, you gotta love it. So this one is, again, a traditional math questions that you see in everyday quizzes and tests and assessment tools. The difference is between this and yesterday's type of word problems is that percent, right? That should tell you you're doing percent proportions. Because you're doing percent proportions, you must think of part over base equals rate over 100. I'm just shortening it. Part over base equals rate over 100. Just think of that. In this specific case, one of them is missing. One of your numbers, either it's your part, your rate, or your base. Something is missing. You're going to put the X on it. But then guess what? You'll solve it the same way you did yesterday. But again, it all comes down to whether you put it in the correct spots, if you've done your setup correctly. So in this specific word problem, if we could read it again. But what were we given? You'll always have it over 100. We're given the rate, am I right? Because we're given the percent. That's an easy one. Rate in this world is always the percent. So 2, easy peasy. Now, they gave us another number. 2% of fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? 900, what is that representing? It's the total, right? It's the amount of fixtures that were completed in one day. That's the total amount. And they want to know the part. They want to know how many fixtures from that total will be defective. So guess what? That's what you got to find. You are looking for your part in this specific example.
That'd be 18.
Okay, you did it. How did we do it though?
I times the 100 by 9 in order to make it 900, then I had to times the 2 by 9.
So, what you, yeah, sure, not a big deal. Just like yesterday, you want to find your diagonals, right? And multiply it. So 900 times 2, which is 1600, divided by 100, which is
18.
18. I said 1600, 1800 divided by 100. My apologies. 900 times 2 is 1800. Divided by 100 is 18. So this is, at this point, it's no different from yesterday. You're going to cross multiply, then divide by the third number. You're still practicing your skill of setting up always your problem. And then looking for the missing piece or base or rate or whatever it is, right? Please keep in mind, let's say they gave us an example like this in which they gave us the part, they gave us the base, and the question was, what percent of fixtures came out defective, right? I've realized that those ones, when for some reason, when you actually are given the part, and instead they want you to find the rate, they want you to find the percent. Those are the ones that trip students up all the time. They're always telling me, I don't see a percent, Neil. Is this a proportion problem like the ones we did yesterday? Because I don't see a physical number with a percent in it, right? And I tell them, well, sure you don't see it, but what is the question asking for, right? If the question asks, what is the percent of fixtures defective or whatever, it says it. They're flat out asking you in the question right at the end, what is the percent? It's up to you to know that, oh, in this specific example, they want me to look for the rate. They want me to look for the percent. Now it's all dependent on whether you got your part and base in the correct spot.